Okay, today we're going to talk about ratios. Okay, and how many people heard of ratios like 2 to 1? Things like that. Yeah, that's what we're going to talk about. Like let's say there are boys to girls. You know, the ratio of boys to girls in the classroom was 2 to 1. You know what I mean? So that's the kind of thing we're talking about. So write this down. This is a definition. You can use ratio to compare two quantities of same kind. So if they're same kind, depth, and then you have to have the same units, even though they're same kinds, like days to hours or things like that. Okay, even though they're the same kind, we're talking about length of time. You have to have same units when you're talking about ratios. Okay, and it could be not only two quantities, but it could be two or more. So the ratio, you know, doesn't have to compare two things. It could be three. Okay, so write this down. It says you can use ratio to compare two quantities of same kind. And remember that you have to have the same unit. Even if they may be the same kind, you have to use the same unit. Okay. There are three ways to represent ratios like 2 to 1. Okay. You could actually use that word 2 to 1. You know that word 2. Or you could use colon, or you could use division symbol, like division bar. So on your homework, they may ask you to represent the ratio in many different ways. Here are the three ways of representing. But all these you read 2 to 1. Okay, that's how you read it. Okay, but you could write it in different ways like this. So write that down. I'm sure a lot of you already knew. Okay. Okay, and so let's talk about some rules. When you writing ratios, there's some rules you got to follow. First of all, we talked about units. What do you have to make sure? Both the units must be same. So first, express measure in the same unit. Okay, that's the first rule. Second is to always simplify. Well, we do that anyway, right? When we solve or simplify expression, you want to simplify first, right? Before you move on. But ratios, you have to really simplify, otherwise, you know, it kind of, you know, it's always best to simplify. It's much easier. Third rule is that order matters. In other words, like the ratio of 2 to 1 was boys to girls, right? So if the ratio of the boys to girls was 2 to 1, which one do you have more, boys or girls? Boys. No, if the ratio was 2 to 1, you have more boys, right? That would be different than 1 to 2. Does that make sense? The order matters. And lastly, write this down. No units. Okay. When you have when you represent ratios do not have units. Okay. So you cannot write 2 meters to 1 meter or something like that. Okay. So write these down, and we'll talk about why there's no units in a minute. Okay. So write this down first. So first, you must have same units. Second, you gotta always simplify. Third, the order matters. You know, whichever comes first matters. It matches what you're talking about. And no units. Okay. Ratios do not have any units. Okay. All right. So who thinks they know why the ratios don't have any units? So let's say we're comparing the length of like height of something. Okay. Height of two things. Maybe it's 2 meters to 1 meter. How come we don't have any units for these? How about Spencer? Any guess as to why? Kind of. Let me. Let's say I have 2 meters over 1 meter, right? Look, I could write it as a fraction this way, right? The ratio. Guess what happens to meters over meter? The unit. Yeah, the same units, they cancel out. Okay. So ratio, since we're using same units, we don't have any units for ratios. Is that okay, guys? Are we good? Okay, so that's why that's important right here. So let's do some examples. These are just some background, right? Things you need to know about ratios. Let's actually get into some of the problems. Okay. First example is really simple. It says express the ratio 3 to 8 in 2 different ways. So one of the ways, write the word 3 to 8. You use the word 2. Okay. Of course, the answer is what? How about Lindsay? Comma or colon? Okay. 3 colon 8 and then? Yeah, 3 over 8. But even though you write it this way, we just, when you read it, it's 3 to 8, 3 to 8. Okay. So anyway, so that's easy. All right. Yeah.
When it's saying to express it in two different ways, does that mean two different ways than what they already
Yeah, than what we already used. Exactly, yeah. All right, let's move on to example 2. Next, let's take a look at example 2. It says write each ratio in simplest form. So I have two ratios for you, 45x to 30x, and then, okay, try to hide the answer here. 18, well, let's just do A first, okay? Go ahead and try A first, we'll do B in a minute. 45x to 30x, how would you write this in simplest form? Okay, how about Dakota? Yeah, divide by 15, right? What would you get? 3x to 2x. Okay, that's really close, but what about the x's? Can't you cancel out those x's too? So what do you get, basically? 3 to 2. Okay, does that make sense? So yeah, you could write this as a fraction. I think that's the easiest way. And doesn't this kind of remind you of what we've been doing in previous chapter? Right, simplifying these fractions and so forth. So you could divide top and bottom by really not just 15 over 15, but 15x over 15. You could think about it that way. Or you could think of it as, you know, you could separate this 45 over 30 times x over x. That's what it is, right? And x's cancel out, you get 3 over 2. Then try this one yourself. 18ab squared over 14a squared b squared. Okay, go ahead and write this in simplest form. Okay, go ahead. All right, how about Carolyn? What'd you get?
I got 9 over 7b, 9b over 7a.
Yeah, 9b over 7a is what you get, right? Because a is canceled out, b is canceled out. You have more a's on the bottom and then more b's on the top. And of course, 18 and 14 you could divide top and bottom by 2. Easy enough? All right, let's do some more interesting ones. These are pretty straightforward, okay? What if I ask you this? Part C. 5 days to 18 hours. Okay. 5 days to 18 hours. Would you write 5 to 18 for this? No, okay, that'll be wrong. Yes, you need to convert either days into hours or hours into days. As long as they both have same units. Which is easier? Days to hours or hours to days in this case? Yeah, days to hours. Because 18 hours, to convert it into days, you get some fraction, right? Or decimal. Okay, so sometimes it may be easier to change it to days if the hours is factors of 24 or something like that, right? But anyway, this time it's not. Go ahead, everybody try. I'll wait. Okay. All right, Aiden, what'd you get for this?
I got 20 hours to 3 hours.
20 hours to? Okay, listen. How many people got 20 hours to 3 hours? Okay, almost, but what happens to units? I told you. So Aiden, you want to change your answer? What should the answer be? 20 to 3? Yeah, you can't do 15 over 18. So you get 20 to 3. Notice I multiplied 5 times 24 and didn't really multiply 5 times 24 out. Why do you think I didn't multiply it out? I could have multiplied 24 times 5 and then try to simplify whatever that is over 18. But how come I didn't multiply it out? Do you see what I did here, guys? I just left it as 5 times 24. I didn't multiply this out. Right? I just kind of left it this way. Why do you think I did that? Okay, how about, yes, Dana? Yeah, because I noticed that these are factors of the whole numerator. Remember fractions, we want to leave a factor. You guys remember from last time? Because you could cancel things out, right, if you leave a factor. So what goes into 18 and 24? 6. So I could, how many times is 6 going to 18? How many times is 6 going to 24? 4. You see how, you know how like for fractions, we like to keep things factored on the numerator and the denominator? Because things might cancel out. You see what I did? So you could have multiplied out and simplified. You still get 20 over 3, but it's a bit easier, isn't it? Okay. So take a look at this. This is a key concept for this section. So write this down. So we're going to be doing some word problems involving ratios. So when you solve a word problem involving ratios, you may need to express a ratio in a different form. Okay? How so? What kind of form are we talking about? If two numbers are, for example, in the ratio of 3 to 5, you can use something and something to represent them. So I want you to think about, so imagine that you have a word problem that involves a ratio of 3 to 5. Maybe it's the ratio of boys to girls again, something like that, okay, in a classroom. If the ratio of boys to girls is 3 to 5, does that mean that there could only be 8 people in that class? No. It could be what else? 6 and 10. It could be 300 and 500, right? This ratio is in the simplest form. It does not necessarily tell you, right, exactly how many number of students are in the classroom, right? Does that make sense? So we can't really use 3 to 5, 3 and 5. So it says when you may need to express a ratio in a different form. How would you use this ratio 3 to 5 in different form? I want you to all think about this as a group. I'll wait and tell you the answer in a minute. Okay, go ahead. What do you guys think? All right. How about Livy? What did your group come up with? What do you guys think? You don't know? Okay. And did anybody come up with a nice answer for this? Yeah. What did your group come up with? Not quite. So let me. Yeah. Yes. What did you guys come up with? You want to keep the ratio to 3 to 5, right?
Yeah.
So
12 to 12 to 20.
no. So that's a particular case. What if it's not just 12 to 20? Yeah. There's a way to represent this ratio. Yeah. That's what we have, 3 to 5. How would you represent it a little bit differently, so that the ratios keeps on being 3 to 5? Yes, Dana.
I just had multiply
With? You guys close. It's actually, you want to represent it as 3x2. Let me 3x to what? 5x. Because why? Why would you want to do that? And we know that 3x over 5x is the same as 3 to 5, right? Why do you think I want to, when I do a word problem that involves a ratio like this, that I want to represent this ratio as 3x to 5x? Michael?
Because then it could be any number?
Yeah, then it could be any number, and it'll keep the ratio to 3 to 5 all the time. Does that make sense? Right? Because if you're just stuck with 3 and 5, you just sort of, left with 8 people all the time or something like that, right? The total number of things that you have is only 8. Here's what I mean by this, okay? So you may think, why do we do this, okay? But take a look at this example now. Okay, go ahead and write this example. It says the ratio of boys to girls is 5 to 4. If the total number of students is 981, how many boys and girls are there? So we know that the total number of students are not 9, right? Because it says 5 to 4. Yeah, so go ahead and write this down. But there are 981, in fact, students, right, altogether. So how are we going to do this problem? This is really not that hard when you think about it. So write this down and think about what we just talked about. If the ratio is 5 to 4, how would you want to represent the number of boys and girls as? Okay, so I'll wait. Go ahead, everybody, try it. Okay, go ahead and talk with your group. Help each other out. How would you represent? By the way, it's a word problem. So what are we going to use to solve word problem? 5-step plans. Yes, and you need to declare variables and so forth. Step 1 was to read this. We read it. Well, how many unknowns do we have in this? How about Lynette? 2. What are they, Lynette? Yeah, how many boys and how many girls there are. So how would you represent number of boys and number of girls if they told us that the ratio, here's a hint, is 5 to 4. So how about Patty? What do you think? Let
5x equal the number of boys.
Very good.
4x equal the number.
You got it. Do you see why we need to use? This is the important step. Why would 5x represent number of boys and then 4x represent number of girls? By the way, does the order matter? They talked about boys to girls. So 5 goes with the boys and then 4 goes with the girls, right? The order matters, I told you. So why is it 5x to 4x? Why can't we just do 5 to 4, something like that?
Because it's gonna.
Who could answer that? How about Chuck?
Sorry, I was writing down.
Oh, okay. So why do we have to use 5x to 4x as to represent number of boys and girls? Why not just use 5 for number of boys and 4 for number of girls? That would give you a ratio of 5 to 4.
Because x is the number of x is
Because if you did that, how many boys and girls do we have? How many students do we have altogether if we just do 5? Yeah, there are only 9. Right now, do we have 9 students? How many? We have 981. So you can't use 5 and 4 only, right? But because we want to keep the ratio same as 5 to 4, do you see why we use 5x to 4x? Because no matter what x is, the ratio would be always what? What would the ratio of boys to girls be? It will remain 5 to 4. The ratio would remain 5 to 4. Do you see why we use 5x to 4x? Does this make sense, guys? The reason is because we wanted to keep this ratio of boys to girls to 5 to 4. That's why we represent number of boys and girls this way. All right, then let's use the formula. How do you find? Because if you want to come up with an equation, you need a formula, right? What's the formula for total number of students? How about Paige? What would the formula for total number of students be? 5x over 4x. That will give you total number of students. If 5x represents 5x plus 4x will give you number of, right? Because the formula is really number of boys plus number of girls will give you the total number of students, right? Therefore, 5x plus 4x gives you 981. Okay, and do we know how to solve this equation? Yeah, you all know how to solve this, right? Is x the answer that we're looking for? Would x give you the number of boys and girls? No, it doesn't. X does not represent number of boys and girls. Yeah, but you have to plug it back in. Very good. Go ahead, everybody try. I'll wait. And tell me the answer. You have to write it in a sentence. Remember, you guys remember? And when you're done, you can always check also, right? Go ahead, everybody try. All right, now that you have some time, how about Angel? What'd you get? So what do I do after this? So let's solve this equation. 9x equals to 981 is correct, and of course it's 5 plus 4, right? X equals 981. And when you divide, what do we get here? How about how about Samara? What'd you get? 109. How many people got 109? Raise your hand. Okay, is this our answer? Good. Is this our answer?
No.
Okay. So then what do we do to find the answer, Royce?
You plug it back in.
Plug it back in, right? So how do I get number of boys then? What are you going to plug x to? 109 times 5. Very good. That's what we said, right? Number of boys was 5x. So since we got x equals 109, how many people got 545? All right. Who's got the number of girls then? How about Bella? What'd you get? 436. I think that's correct. Very good. So there you go. Did you write it as a sentence? There are 545 boys and there were 136 girls. How do we check the answer?
You add them.
Okay, good. You could add them together, and is that all? Like, okay, so when we add them together, it should add up to what? 981, and it does, doesn't it? Is that all we need to check? Also, the ratio of boys to girls has to be what, guys? 5 to 4. And of course it does, because if you were to divide 545 and 436 by 109, right? Because that's how we got these numbers, right? 5 times 109, you got 544, 545, and 4 times 109, it was 436. We good? Can you do something like this for your homework tonight?
Yes.
Let me give you one more, and this time I'm going to have you do it by yourself. Why don't you try this all yourself, by yourself? Okay, I'm sure you could do this. This time, not only are we comparing 2 numbers, we're comparing 3 numbers. The height of 3 brothers are in the ratio of 13 to 14 to 15. Their combined heights equals to 210 inches. Find the height of each brother. How many unknowns do we have here, guys?
3.
There are 2? There are 3 unknowns, right? Because the ratio is comparing 3 heights of 3 brothers. Go ahead, see if you could do this. It's very similar to the one we just did, except now you have 3 unknowns. Okay, go ahead. All right, as we said before, there were 3 unknowns, so we need to declare a variable for each of these 3 unknowns using one variable. Again, Jason, what would you do?
Oh,
Let
13x equals the first brother.
Good.
13x is the second.
Right, and so on.
13x
So, and this is the most important step, right? We need to recognize that 13x to 14x to 15x will still give you that ratio of 13 to 14 to 15. It will keep that ratio. That's why we need to declare our variable this way. Very good. And what's our equation that we need here? How about Joseph? What would the equation of this be?
13x plus 14x plus 15x equals 20.
Exactly. When you add them all together, it equals to 210, doesn't it? Because that's the formula, right? How do you figure out the total height? You add them all together. So when you add them together, did you all get 42x equals to 210? Divide both sides by 42. Did you get, how many people got x equals to 5 as x, answer for x? Very good. Is this our answer? No, now we need to?
Plug it in.
Very good. How many people got, when you plug it in, how many people have the answer as 65 to 65 inches, 70 inches, 75 inches? Good. Easy. Can you do this for your homework for tonight?
Yes, we can.
All right. So remember how you declare a variable, okay? Any questions? Very good. All right.